How can we combine like terms by applying our understanding of variables and like terms? So a variable is a letter that stands for a number. So maybe it's X or Y or any letter, W, T, etc. And when using variables, we can show multiplication in lots of different ways. So for example, here I see we have 3 times A. One way we can write it is kind of like the way we grew up, writing this X. So 3 times A is one way. Another way is 3 and then using this dot. Another way is simply putting the letter next to the number, the variable next to the number, so 3a, this is another way. And then finally, if we separate a number and the variable with a parentheses. And we're going to be calling this number a coefficient. We'll talk more about that in a little bit. So these are some ways you can write multiplication. We can also show division in a few different ways. So here we have 4x divided by 5. And one way we can do that is write 4x over 5. Another way we can do is simply 4x divided by with the division symbol by 5. Easy, right? Okay. So here we've got a few more examples, and we're going to be talking about like terms. So like terms have the same variables with the same exponents. So here's an expression, and we can see that there are no like terms. I know that this part right here, the -4, is what we're going to call a coefficient. The -4 is our coefficient. We just learned what these letters are called. These letters are called variables, and we've got 3 terms here. We've got -4y, we've got positive 6x, and we've got -xy. If it said maybe -7, a number without a variable is going to be called a constant. And it's not critical that you remember this vocabulary, provided that you know how they work together. So like terms have the same variables with the same exponents. So here I see we've got 3xy and -xy. These have the same variables with the same exponents. So even though we don't see it, there's a little invisible 1 exponent for each. They're totally the same. And even though there's no number in front of the x right here, we know that there's a sort of like an invisible 1. The coefficients can be different. The variables and the exponents have got to be the same. So 4a and 3a are like terms. I know that because they've both got the same variable. And here we have -x squared and 2x squared. I can see that they've got the same variable, x, and they've got the same exponent. Nice. So what do unlike terms look like? X and y, they're not the same. A and AB are different because even though they both contain A, they're not the same variables. And what we're going to be doing is we're going to be combining like terms. So here I see we're going to be adding in this expression 5n plus n. Well, what do I know? If there's not a number in front of the variable, we're just simply going to add a 1 as our coefficient, and 5n plus 1n, 5 plus 1, is 6, and we're going to tack on that variable, 6n. Easy. Let's take a look at another one. Here we have 6x squared plus x squared plus 9x squared. All the variables are the same, right? X. We've got different coefficients, and we can add 1 right there so we don't get confused, and the exponents are all the same. So I know that 6 plus 1 is 7, so this is going to be 7x squared, and now we're going to bring down -9x squared, minus 9, and when we do that, 7 minus 9 is going to give us -2, so the answer is -2 squared. There we go. And here we've got another example of combining like terms. We've got 2 different variables in here. So sometimes when things get a little tricky, I like to draw squares around like terms to represent one, and then maybe circles around another to represent a different one so I don't get confused. Now these are next to each other, so it's pretty easy, but you'll see when things get a little complicated, this tactic will help us out. 3x minus 6x is going to give us -3x, and here we've got -2y plus 8y, and that's going to give us -2y plus 8y is going to give us positive 6y. And that's it. We can't simplify any further because there are no more like terms. This is our answer. All right, ladies and gentlemen, you guys are going to work on page 39, combining like terms. If you have any questions, please let me know. Good luck.